In section 4.2, we are still focused on graphing sine and cosine. So far, we have tackled those values for A and B. We've talked about amplitude changes, we've talked about period changes. Now we're going to talk about phase shift, and we're going to talk about a vertical translation, our shift away from a center on the x-axis. Now, our pattern of transformations, remember whether it's sine or cosine or any of the others really, is going to follow the same pattern. C is our vertical shift, it's a change in center. A changes our value for that amplitude, how high and low we go. Then we have our function, either sine or cosine. At this point, it could be any of the trig functions. We're going to have a value for B here, and then assuming that has been factored out, D is our phase shift. So B changed our period. D is going to be what we work with as our phase shift. And a phase shift is simply a horizontal translation. Horizontal translation. So center or peak, if you're doing cosine, that first major point is no longer at 0 radians if I have a phase shift. I've shifted it away from that y-axis, away from 0 radians. The argument here is this expression x minus d. Notice that just like in college algebra, when we were talking about a horizontal shift, it starts as x minus. So whatever gets plugged in there is going to be changed by that sign. So you have to think of, a couple of different ways. You think about doing the opposite. You think about setting it equal to 0 and solving, however you want to think about that. But you do have to adjust for the fact that it starts out as x minus. Horizontal translations. The graph of this function where we have x minus d is translated horizontally compared to the graph of the function y equals f of x. That translation is d units to the right if d is positive, and it's d units to the left if d is negative. Now, make sure you're paying attention. That's not what sine is showing, that's what value of d I have plugged in. So, just to be super, super clear, if I have a pi half here, x minus pi half, it starts as x minus d. This means I have plugged in a positive pi half and I'm shifting it to the right. That's what that one means. If it looks like this though, because it started out as x minus and now it's x plus, that means I plugged in a negative pi half and I'm shifting it back to the left. Okay. We are going to start without a value of b that has to be factored out so we can focus on what this phase shift does to our graph, and then we will throw in that value of b as we move on. All right, here we go. We're going to graph sine function. We know sine starts at center. A is just 1. A would be out here. A is just 1. B would be right here in front of my x. B is also 1. So the range of this function is from -1 to 1. The period is just 2 pi, because when I plug in b, I've just got 2 pi. But I am not going to start marking points on my x-axis yet because I have a phase shift. Now, what is my phase shift? This is the important new piece that we're working on. My value for d that I've plugged in here, did I plug in a positive or a negative? Well, it's x plus here, so that means I plugged in a -3 pi fourths, and I'm shifting my function to the left. It's a negative value for D, so I'm shifting it to the left. Now my period, we said, is 2 pi. So my interval size is that period divided into 4 equal intervals. 2 pi divided by 4, that's pi half for my interval size. Or 2 pi fourths, right? Depending on how I need to use it. And I say how I need to use it because my first point is not at 0. Up until now, my first point has been at 0 radians. Now my first point is at a negative 3 pi fourths. Negative 3 pi fourths. That's my first point on my x-axis, that first major point that I'm going to graph for my sine function. So when I do my major points, I start at negative 3 pi fourths, my phase shift, not at 0. Now, what's the size of the interval? It's pi half, but if I'm going to add that interval on, I need to have the same denominator. So I'm going to add 2 pi fourths. So negative 3 plus 2 puts me at negative 1 pi fourth. Negative 1 pi fourth plus 2 pi fourths puts me at positive pi fourth. Plus 2 pi fourths puts me at 3 pi fourths. That's 4 points. I need to go one more. Plus my interval size, 2 pi fourths, puts me at 5 pi fourths. These are my 5 major points. 1, 2, 3, 4, 5. If I look at the difference between negative 3 and positive 5, the difference between negative 3 and positive 5 is 8 pi fourths. The difference there is 8 pi fourths. That is the same thing as 2 pi. That's the correct period size, so that checks. We're in good shape. Now notice that 0 is not one of my points. So when I mark my x-axis, I've got negative 3 pi fourth, negative pi fourth, positive pi fourth, positive 3 pi fourth, and positive 5 pi fourth. That is one period of my function. 4 equal intervals. 1, 2, 3, 4 equal intervals divided into 5 major points. Let's graph our function. Now, the key here is not to put a major point on my y-axis because I haven't found a y-intercept this time. Graphing positive sine function, sine starts at center and goes to peak if it's positive. So we're starting at center. There's my first point. Up at peak for my second point. My third point is over here, not on the y-axis. Down to center. So center, peak, center, then trough, and then back to center. That is one cycle, one period of this sine function that has a phase shift to the left of 3 pi fourths radians. Okay, let's do a cosine function. Now, things to note. This is negative cosine, so instead of starting at peak like a positive cosine, we are going to be starting at trough because it's a negative cosine. So let's go ahead and write that down. We're going to reflect over the x-axis because it's negative. This is a value for A. A is 2. So my range is going to be from negative 2 to positive 2. B is just 1. I don't have a value in front of my x other than 1. B is 1, so the period of my function, we're keeping that part standard for right now. My period is just 2 pi. The new thing, the thing that we are focusing on new here, is this value for D, this phase shift. Now, it's x minus, so that means I have plugged in a positive pi third, and my phase shift is going to be to the right. My first major point on my graph is going to be at a positive pi third. And I know that I want to divide my x-axis into 4 equal intervals from that pi third. So let's figure out what that's going to look like. My interval size, 2 pi divided by 4. Okay, so that's pi half. My first point out of the 5 points is at pi thirds. I don't have a common denominator yet. I need a common denominator here. Well, the common denominator between 2 and 3 is 6. Pi third is the same thing as 2 pi sixth, right? Pi thirds is the same thing as 2 pi sixth. You got to do some work with fractions here. That's why we started out the semester with that orientation question that we did. Pi half, my interval size, is the same thing as 3 pi sixth. So from my first point, I'm going to be adding this interval size, 3 pi sixth. So 2 pi sixth plus my interval gets me to 5 pi sixth, plus my interval gets me to 8 pi sixth, which is going to simplify, plus my interval gets me to 11 pi sixth. That's 1, 2, 3, 4. I need to go one more time. Plus my interval is 14 pi sixth. So we need everything in lowest terms. Pi third, 5 pi sixth. This one would be 4 pi third, 11 pi sixth, and then this one would be 7 pi third if I put everything in lowest terms. So those would be my 5 major points. Let's look at the difference and make sure we've got our period right. The difference between 1 pi third and 7 pi thirds, that difference is 6 pi thirds, which is 2 pi. That's the correct period. So we're good. The difference between the first and the 5th major point, that first point and that last point. All right, so let's label our x-axis. Pi third, 5 pi sixth, 4 pi third, 11 pi sixth, and 7 pi third. Everything is in lowest terms. I've labeled my x and my y-axis. These things are necessary. You've got to have them on your graph. The side work is helpful to you and to me as I grade your work. It keeps you straight. It makes sure that you've done everything. You've evaluated everything you need to for the function. Numbering your x and y axis, labeling things on your graph is essential. Okay, what are we graphing? Well, we're graphing cosine. Cosine starts at peak, except this is negative cosine. So instead of starting at peak, we're starting at trough. And my first point is not on the y-axis. I have a phase shift. My first point is over here at positive pi third. So negative cosine starts at trough. My first point, because of my phase shift, is at pi third, negative 2. There's my coordinates. I'm going to go up to center, peak, center, back to trough. And there is one cycle, one period of my negative cosine function. I start here, I finish back here at trough. I've got a peak point at 4 pi thirds 2. I've got centers at 11 pi 6, 0, and 5 pi 6, 0. I'm plugging in angles. I'm getting out function values. Excellent. Okay, let's do another couple of examples. Well, we're going to do one more example like this, and then we are going to throw in that vertical translation where we shift up or down. Okay, so here we go. Now, notice that I am throwing in a value for b. When I am given my problem, that value for b is not factored out of my expression x minus d. So I want you to think about this in just general terms from college algebra. If we had, in college algebra, if you had 3x plus 6, and I told you to factor out your common factor, you'd say, okay, well, I'm going to divide both of those by 3, right? 3 divides out, and I'm left with x plus 2. So that would be factoring out that 3. This is what we need to do here. We are given 2x minus pi, and I need to factor out this 2. That's my value for b. B is going to be 2. But as my equation is given to me, as my function is given, it is not factored out of that expression, so I don't have a value for d yet. If I factor out that 2, that means I divided it out of this first term. I also need to divide it out of this second term. So my value for d is not pi, it's pi half. This function becomes 3/2 cosine 2 times x minus pi half when I factor out that value for b. Okay, we've got that factored. Now let's do all the things. We've got a value for a of 3/2. We've got a value for b of 2. And we've got a value for d of a positive pi half. So what does that mean for us, for our graph? Well, this value of a being 3/2 means my range of my function is from negative 3/2 to positive 3/2. That's my amplitude, right? So 1, 2, 3/2 is going to be right there, halfway between 1 and 2. 1, 2, 3/2 is going to be right there, halfway between -1 and -2. We have a value of b as 2, so that changes my period. Period is 2 pi over 2. My period for this function is going to be pi. Not going to mark that yet because I have a phase shift. My phase shift goes to the right because that value pi half is positive. So that I can mark. I can say, okay, well, I've got a positive pi half as my first point on my x-axis, and then I'm going to need 4 more points. So 1, 2, 3, 4, 5 major points. That's going to get me my period. My period is pi radians. So if I start at 0 to pi, it would be pi, but if I'm starting at pi half, it's pi plus that pi half, which is going to mean this last point is going to fall at 3 pi halves. Let's come over here and let's do our regular work that we do. Our interval size is always the period divided by 4. That is what it is. My first of the 5 points is at pi half, and I need to add pi fourths to that. So you know what? We're going to make that a common denominator. Pi half is the same thing as 2 pi fourths. To get from one point to the next, I add 1 pi fourth. So 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, 1, 2, 3, 4, plus 1 is 6. There's my 1, 2, 3, 4, 5 major points. Some of them simplify. Pi half was my 2 pi fourths. 3 pi fourths doesn't simplify. 4 pi fourths is just pi. 5 pi fourths doesn't simplify. 6 pi fourths is that 3 pi half. We already checked. We knew that was where we needed to end up, so we're in good shape with our period being pi. So now let's think about what our graph's going to look like. We are graphing cosine. Cosine starts at peak when it's positive cosine, and this is. So we're going to start at peak. Well, where's my peak? My peak is at this 3/2. My first point falls here, not on the y-axis, not at 0. So my peak is here at 3/2. Positive cosine goes peak, center, trough, center, peak. And I draw my curve through there. That one looks a little squiggly. Sorry, it's not a very balanced curve. But that is what my function, oh no, over 2 periods. So I've got choices to make here, guys. I'm either going to have to go back and make sure that I do the correct values in a negative direction, or, and I'm just going to do this because that's the easiest way to go, I'm going to extend it to the right for a second cycle and say, let's just keep adding fourths. If I add a pi fourth here, this was 6 pi fourths. That one's going to be 7 pi fourths. 8 pi fourths is 2 pi. 9 pi fourths. 10 pi fourths is 5 pi halves. Is that enough? We've got 1, 2, 3, 4, 5. That's enough. So my second cycle, we're at peak. We'll go center, trough, center, and then back to peak again. There's my second cycle. So we've got one period or cycle, and we've got one period or cycle. Okay, excellent. That gets us some good experience with our phase shifts, throwing in values for A that are different amplitudes and adjusting the period of our function. The last transformation that we need to do is that vertical shift, that vertical translation up or down. My graph is translated vertically compared to the original function if I have this value of C added on at the beginning or added on at the end. If C is positive, greater than 0, we're going up. If C is negative, if it's less than 0, we're going down. So it goes the way we expect it to go. For example, right here, I've got a -2 added on at the beginning, tacked on at the beginning. That's my value of C. C equals -2. That means I'm going down with my center. So the very, very, very first thing I'm going to do is mark that center. I'm going to say, oh, look at that. Center is not on my x-axis. Center is right here at -2, because if I don't do that, I mess up my graph. I forget to adjust for that vertical shift. What else do we have going on in this graph? Well, we've got a value for A that's not 1. We've got A is 3. So that's an amplitude change. We've got a value for B that is 2. So that's a period change. And we're told we're going to graph this over 2 cycles. Amplitude change. Now, my amplitude is from center. So the range of this function is not -3 to +3. I'm going 3 units from center. So from center, 3 units up puts me at 1. And from center, 3 units down, -2, 3, 4, -5. So my range for this function is from -5 to 1. Total of 6 points because my amplitude is 3. From center, I go up 3 units. From center, I go down 3 units. The other adjustment I have is to the period of my function. B is 2. We already have figured out by now several times that 2 pi divided by 2 is pi. So the period of my function is pi. Did not throw a phase shift at us, so that's nice. We don't have to worry about a phase shift with this one. Since we're doing 2 periods, we get to start at 0 because there's no phase shift. I'm going to go pi units to the right, and I'm going to go back pi units to the left to get both of my cycles or periods in. Each of those periods needs to be divided into 4 equal intervals. We get to start at 0. The interval size is pi fourth. We get to go 0, 1 pi fourth, 2 pi fourths, 3 pi fourths, pi. There's my points. This is easy because I'm adding to 0. I can go back in a negative direction the same way. And I've got my x and y axes labeled. Now as I start doing my function, I need to pay attention. I'm graphing cosine. It's positive. Cosine starts at peak. I do not have a phase shift. No phase shift. So my first point, my major point, gets to fall on the y-axis. At peak, where is peak? Well, peak is at 1 because I'm going up 3 units from center. Peak is at 1. We're graphing cosine. We're going down. Center is down here at the center I drew. Trough is all the way down to -5, back to center, and then back to peak at +1. Need 2 cycles, so we got to go the other direction as well. Peak is +1. So there's my graph, my positive cosine function. It has a horizontal compression and a vertical stretch. We've got one period here and one period there. We've got a peak at negative pi 1. We've got a trough at negative pi half negative 5. We've got a peak at 0, 1, a trough at positive pi half negative 5. We've got a center here at 3 pi fourths negative 2. We've got a center here at pi fourth negative 2, etc., etc. I want so bad to ask any questions because I'm sure there are some out there. I encourage you guys to be using the Math Lab tutors from TCC, to be using all of your homework helps on my Math Lab online. Whatever you need, email me, ask my instructor link questions, we can meet, you know, just let me know what you need. Okay, combinations of translations. So when we are graphing sine and cosine functions, where b is greater than 0, so this value here, my period change, is going to be greater than 0, and we're going to keep that consistent for this semester. We're not going to do anything weird, no negative values for b, which involves stretching, shrinking, and translating. You're going to graph them according to these 5-step guidelines. First, you find the interval whose length is 1 period, 2 pi over b. And by factoring out b to find that phase shift, if you have a phase shift, divide the interval into 4 equal parts, evaluate the function for each of the 5 major points. Those points are our maximum, minimum, and that intersect the center line, whatever c is, y equals c. Plot those points with a curve with an amplitude of a, whatever the absolute value of a is. Remember, if a is negative, that's not my amplitude. That tells me I'm reflecting. And then I do as many periods as I need to do. If it asks me for 1 or 2 periods, I don't think it's ever going to ask you for more than 2 periods or cycles of your function. Okay, we got just a couple more to put it all together, and then we are going to do an application problem. Here we go. We have all the pieces here, right? We've got A, B, C, and D. Let's just do them in alphabetical order. I kind of like that. So this is my position for A, the coefficient on my function. A here is negative 2. That negative tells me that I'm going to reflect over the x-axis. So I have a negative sine function. We're graphing negative sine. I always make notes so I don't forget. Sine starts at center. Negative sine goes from center to trough instead of center to peak. That's my value for A. I can't do range until I see about center. B is going to be 3. That's going to change the period. So the period of my function is 2 pi third. C is 4. That's my line of center. So now we can start doing some stuff. Now we can start making some marks over here on our graph. We're going to go up 4 units to find center. So let's do that. Let's do 1, 2, 3, 4. There is my center line. Function is not going to be centered on the x-axis. It's centered up here at y equals 4. My amplitude, we said, was 2. So from center, I'm going to be going up to 6, and from center, I'm going to be going down to 2. So the range of my function is 2 to 6. The last piece of information I have is my phase shift. My phase shift is my value for D. Phase shift is not pi. I've got to divide out that B. If I divide that out, 3x divided by 3 is x, pi divided by 3 is pi third. So D is a positive pi third. My phase shift is to the right. My phase shift is to the right. So the very first point on my graph is going to be a positive pi third. Interval size. Well, my period is 2 pi third. I got to divide that by 4 to get my interval size. So 2 pi third divided by 4 is times a fourth. Gives me 2 pi 12th, which is just pi 6. That's the size of my interval. Let's think about where those points are going to fall. My first point is going to fall at pi third. I need to add pi 6 to that. So I'm going to need a common denominator here. My common denominator is going to be the 6. So pi third is 2 pi 6. That's my first point. My interval size is that I'm going to add on pi 6 to that. So 2 pi 6 plus 1 is 3 pi 6 plus 1 is 4 pi 6 plus 1 is 5 pi 6 plus 1 is 6 pi 6. 1, 2, 3, 4, 5. But I've got 2 periods, so I need to keep going. There's one cycle. 6 pi 6 to 7, 8, 9, 1, 2, 3, 4, 10 pi 6. So right here, 2 pi 6 to 6 pi 6 is 4 pi 6. That's my difference between these 2 points. 2 pi 6 to 6 pi 6. One cycle gets me to 4 pi 6, which is 2 pi thirds. And that is the right period size, so we're good. All right, let's mark our points here. And mark off some points that are equidistant to each other on the x-axis and see how far we get. So pi third, 3 pi 6 is pi half, 4 pi 6 is 2 pi third, 5 pi 6, pi, 7 pi 6, 8 pi 6 is 4 pi third. 9 pi 6 is 3 pi half. 10 pi 6 is 5 pi third. And we've done all of them. That worked. Excellent. Okay. So, what are we graphing? Well, we're graphing negative sine. Sine starts at center. Negative sine goes down. Not going to have a y-intercept here. My first point is at pi third. At center, which is at 4. And negative sine means I go center to trough, which is at negative 2. Back to center to peak. I'm going to have a hard time keeping this balanced. Back to center to trough, center, peak, and back to center. Let's see how we did. Not bad. Looks pretty good. Alright, so I've got 2 cycles, 2 periods. I go from here to there is 1, and then to there is a second period. Let's label some coordinate values. This peak, well, let's start here. Center, pi third and 4. This is pi half at 2. 2 pi third back to 4 is my center again. 5 pi 6, I'm up here at peak at 6. And then you can see I'm just moving forward. Excellent. All right. Please remember that the beauty of these videos is that you get to pause and rewind, go back over, take a second to work it out on your own, and then look at it again together. Okay, we have all the things in this one again. We have all the things. We're asked to do 2 periods. I see that I'm going to have to factor out my value of b. So I'm going to go ahead and do that. I'm going to factor out that 4. When I divide out 4, I also have to divide out 4 here, so that gives me pi fourth. That is my argument for sine. So I've got negative 1 plus 2 sine. There's my equation. Okay, let's do it. A, B, C, D. A is 2. That's my amplitude. B is 4. That adjusts my period. C is negative 1. That's my center. D is positive or negative. D is a negative pi fourths. That's my phase shift. So my center is at y equals negative 1. My period is at 2 pi fourths, which is pi half. My amplitude is going to go up and down from center. Center's at -1. Up 2 from that, down 2 from that. So down 2 from -1 is -3. Up 2 is +1. All right, let's get our graph built. So center is at -1. -1. From center, I'm going to go up 2. And from center, I'm going to go down 2. So there's peak and trough. My first point is going to be at -pi4. Since it's back here to the left, I kind of need to do some thinking about what happens with the rest of my points. So that's my first point. Let's look at our interval size. Interval size is that period divided by 4. So pi half times 1/4 is pi 8 is my interval size. So when I'm setting up these points, I'm going to think of these in terms of eighths. So -pi4 is actually going to be -2 pi eighths. That's what that is. -pi4, my first point is at -2 pi eighths. And then I'm going to add a pi eighth to move on. So +1 is -pi 8. +1 is 0, that's nice. And then I've got +pi 8, 2 pi 8, 3 pi 8, 4 pi 8. I can do both cycles this direction. I can do one this way and one back to the left. Doesn't really matter. I think I'm going to go everything to the right. If we do, so we do 1, 2, 3, 4, 5. That's one period. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 points is that second period or cycle. Did we measure it out correctly? Well, the difference between 2 pi 8 and 6 pi 8 is 4 pi 8, which is half pi. So yeah, that's a period. The difference between -2 and +2 is 4 pi 8, which is also half pi. That's my period, so we're in good shape. All right, let's mark our function, our points on our function. We need to put things in lowest terms as we do this. My first point here is -pi4, and then I've got a -pi 8 and a 0. So 0, we'll do -pi 8, -pi4. Those are our negative points. We've got a point on my graph at the y-axis this time. That's nice. +pi 8, 2 pi 8 is a pi4. 3 pi 8, 4 pi 8 is a pi half, 5 pi 8, 6 pi 8 is 3 pi 4ths. Yeah, 3 pi 4ths. Okay, so there is our x-axis marked. All right, now we're graphing. Positive sine starts at center, goes up to peak. Where is center? Well, center is at -1. My first point is at this phase shift, -pi4. So center is at -1. So my first point is at -pi4, -1. I'm going to go from center to peak, back to center, and I get to use the y-axis this time because it's one of my major points. Center, peak, center, down to trough, back to center, back to peak, and I'm doing 2 cycles, so I keep going. Trough, back to center. There is my positive sine function graph. 2 cycles, center, peak, trough, center, center, peak, center, trough, center. There's 1 cycle, and there's my second cycle. 1 period here. Excellent. Now, can you start in different places, do different things? Absolutely. This is just the way I organize my thinking to make sure that I get all of the given transformations included in my graph, clearly marked and defined. And I've got black ink all over myself today. Look at that. That's a mess. I'm sorry. Okay, let's do our calculator application example. We are modeling temperature again with a sine function. This time we have not been given all the values and we have to work it out. You know what? I'm looking at the time in our video. This is kind of an extra thing. This is kind of extra, and so we are going to leave it as extra. In my lecture classes, I typically don't always get here. It's kind of depends on the time we have, and we're already at 40 minutes in our video. I think your brains are probably tired. So we're going to just leave this as extra and leave it out for right now. You can find examples like this in my math lab if you're intrigued and want to work through it. I will leave it up to you.